Okay, today we're going to be looking at Module 3, Lesson 4, where we're going to continue adding fractions, and this time we're going to be always getting sums between 1 and 2, which means we're going to have to simplify them at the end, which we kind of practiced with Lesson 3. So, question number 1 says, for the following problems, draw a picture using the rectangular fraction model and write the answer. When it's possible, write your answer as a mixed number. So this is a continuation of Lesson 3's activities. So we're going to be using a rectangular fraction model to find our equivalent fractions. Because when we add 3/4 and 1/3, they have different denominators. Their units are not the same size. So we have to make their units the same size or their denominators the same. So we're going to use the rectangular fraction model to do that. So first I'm going to do 3/4. So we're going to shade in 3 out of our 4. And then we're going to do 1/3 horizontally. And we're going to shade in 1/3 out of our 1 out of our 3. We did this yesterday, and so we're going to be going through this pretty fast today. So to find equivalent fractions, I'm going to combine them, and I'm going to split this 3/4 into thirds. So I'm going to times by 3, times by 3, and I'm going to get 9/12. And I'm going to split this third into fourths. And I'm going to times by 4, and so I get 4/12. So now my new equation is going to be 9/12 plus 4/12. And when I add 9/12 and 4/12 together, because they're both 12ths, so my denominator will stay 12. And when I add my numerators together, 9 plus 4 equals 13. 13/12 is a fraction greater than 1. It's an improper fraction. So I can simplify and write it as a mixed number. Remember that a mixed number is a combination of a whole number and a fraction. So 13/12, I know that I can take away 12/12 from it. And if I take away 12/12 from 13/12, I end up with 1/12 left over. So 12/12 equals 1 whole, and 1/12 stays the same. So 13/12 can be written as 1 and 1/12. Remember that you can also do it with just division and say 13 divided by 12, because every time you see this fraction bar here, you should think division. So 13/12 is the same thing as 13 divided by 12. So 13 divided by 12, 12 doesn't go into 13 one time. And we get 1 as our remainder, so it's 1 and 1/12. So 1 and 1/12. Let's look at B. 3/4 plus 2/3. So again, rectangular fraction model to represent the problem. 3/4. We're shading in 3 of them. And 2/3, we're shading in 2. Now I need to find equivalent fractions because 4 and 3 are not the same denominator. So I'm going to take my 3/4 and I'm going to split it into thirds. So I get 9/12. And I'm going to take my 2/3 and I'm going to split it into fourths. So we're going to times by 4, and we get 8/12. So my new equation is 9/12 plus 8/12. 9 plus 8 will give me 17, and my denominator stays the same. So 17/12, my numerator is bigger than my denominator, so I need to simplify this into a mixed number. I know I can take out 1 12/12, and I'll be left with 5/12, because 5 plus 12 is 17. So I get 1 whole and 5/12 as my leftover. So 1 and 5/12. Also, I can do it like this. 17 divided by 12. 12 goes into 17 one time. I get 5 left over, so it's 1 and 5/12. 1 and 5/12. Okay, 5/6 plus 1/2. Do 5/6. 1, 2, 3, 4, 5, and shade in 5 of them. And then we'll do 1/2, And always make sure you're labeling your pieces so we don't get confused with our shadings, because sometimes our drawings can get messy and it's really our numbers that we have to keep really organized. So let's make some common denominator equivalent fractions. I'm going to take this 5/6 and split it in half, which means I'm going to times both my numerator and my denominator by 2 to get 10/12, because I have 10 pieces now out of 12. And I'm taking my 1/2 and I'm going to split it into sixths. 1, 2, 3, 4, 5. So I'm going to times by 6, times by 6, and I get 6/12. Because now I have 6 pieces out of 12. So when I do 10/12 plus 6/12, I get 16/12, which I know is going to equal 1 whole, because I can take away 12/12. And if I take away 12/12 from 16, I know that 16 minus 12 is 4. So I get 4/12. So I get 1 4/12. This, I feel like I could simplify more. This is a mixed number, yes, but 4/12 are both even numbers, so I can keep this simplification going. So 1 4/12. The 1's going to stay the same. But the 4/12, I can divide each of these by 2 at least, because they're both even. So 4 divided by 2 is 2. 12 divided by 2 is 6. And I can actually divide this by 2 one more time. So I get 1 1/3. Because 4/12 can actually be divided by 4 by 4. And I get 1 1/3. So my final answer here is 1 1/3 when I add 5, 6, and 1/2. Let's practice this with a word problem. Mr. Sinofsky used 5/8 of a tank of gas on a trip to visit relatives for the weekend, and another 1/2 of a tank commuting to work the next week. He then took another weekend trip and used 1/4 a tank of gas. How many tanks of gas did Mr. Sinofsky use altogether? Let's go back and reread and underline that important information. Because the question is, how many tanks of gas did he use altogether? So altogether is kind of giving me this like clue that I'm going to add them together, and I need to figure out the pieces that he used. So he used 5/8 a tank of gas on a trip to visit relatives. So he has 5/8 for relatives. 1/2 a tank of gas commuting to work. And then another weekend trip to use another 1/4 tank of gas. So we have 3 fractions here that we need to figure out and add together, because they're asking for how much gas did he use all together from these 3 pieces. Now, you have 2 options when you're doing this. One, you can find a common denominator for all 3, so like 8, 2, and 4. Or you can kind of do it and just focus at 2 of them at a time and only do, like, almost imagine parentheses and only do 2 at a time and then find your third. You have those options there. So there's kind of 2 ways to solve that problem. It doesn't matter which way you go as long as you are being consistent with how you're going to do it. So I think I'm going to do 2 and then add the third one. So I'm going to start with the smaller numbers first, because I think that's going to be easier for me. So I'm going to do 1/2 plus 1/4. So I'm going to start with my 1/2 and then my 1/4. And then, just like before, we're going to find equivalent fractions. 3. So we times by 4, and so we have 4/8. And then times by 2, and we get 2/8. So now I have 4/8 plus 2/8, which is going to give me 6/8. So my new equation is my 5/8 stays the same. And now I'm plussing 6/8 because I added 1/8 times 1/4 and got 6/8. Well, it just so happens that now 5/8 and 6/8 have the same common denominator. They're the same. They both are already 8s. So I can just add those straight across. 5/8 plus 6/8 is going to give me 11/8, which I know can turn into 1 whole, because I'm doing 11 divided by 8. 1 whole and 3/8 left over. So it looks like he used 1 3/8 of his gas. If you decided to do it where you did 5/8 plus 1/2 plus 1/4, and you wanted to find one common denominator first, you might have it be a little different. Like you might have found that, like if you had done 8.5 first, if I had done 8s plus 1/2, I would have gotten 16 as my denominator, because 2 and 8 are 16. And if I did it that way, I then wouldn't have had the same denominator as 4, so would have had to do another rectangular fraction model to figure out that answer. And that's fine, right? As long as you have common denominators, you can simplify to the most simplistic form at the end. It's okay if you use bigger denominators just based off the numbers that you did. But that's why I decided to start with the 1/2 plus 1/4, because they were the smallest denominators. And it let me do the least amount of big multiplication for numbers. And I was hoping to avoid doing big multiplication, and it worked. I did 1/2 plus 1/4, and we got our final answer. So today was basically a review of adding fractions together with unlike denominators, and the importance of finding those common denominators before we add them together. So we use our rectangular fraction models to find equivalent fractions and then add them together to find our common denominators and then our final answers. And then just keeping in mind that we're going from fractions greater than 1, and we always end with the most simplistic answer possible. So a mixed number, a simplified mixed number. It might be a mixed number, right? Like 1 5/12 is just a mixed number. But sometimes you're going to have to take your mixed number and you're going to have to simplify it even farther, because a mixed number is not necessarily the most simplistic form. So just be aware of your answers. And so when you're doing your math today, make sure that you're all the way done with your problem when you're ready to move on.